A very pleasant good morning to all the esteemed dignitaries, distinguished guests, senior researchers, and all the faculty members who have joined us here today. On behalf of our most respected Honorable Founder President, Dr. Ashok K. Chauhan, sir, and our respected Chancellor, Dr. Atul Chauhan, sir, and Dr. Asim Chauhan, sir, I, Kaushki Shishu, extend a very warm welcome to you all for this insightful meeting with the senior delegation from DRIIV, which is the Delhi Research Implementation and Innovation, the Delhi S&T cluster, under the Office of Principal Scientific Advisor to the Government of India. We are very privileged to have your presence with us here today. At the outset, it is my great honor to extend a warm welcome to our distinguished guests of the day, Dr. Vishal Chaudhary, sir, who was due to join us today, but due to an urgent meeting at the PMO office with Dr. Ajay Soodji, he could not join us today. Apart from him, Dr. Amrita Dawn, ma'am, Senior Innovation Officer, Delhi Research Implementation and Innovation Cluster, Mr. Krishan Kumar Gaur, Head Institutional Relations, DRIIV PSA, and Mr. Arvind Iyer, Program Manager, DRIIV PSA. Keeping up with Amity's welcoming tradition, I would like to request Dr. Balvinder Shukla, Madam, respected Vice Chancellor, Amity University, Uttar Pradesh, to warmly welcome Dr. Amrita Dawn, ma'am, with a Tulsi sapling. Please. I would like to request Dr. Chandradeep Tandon, sir, to kindly welcome Mr. Krishan Kumar Gaur, sir, with the Tulsi sapling. I would like to request Dr. W. Selvamurthy, sir, to kindly welcome Mr. Arvind Iyer, sir, with the Tulsi sapling, please. Thank you, everyone. Today's meeting aims to foster meaningful alignment between academic excellence and national priorities by exploring how Amity University Uttar Pradesh strengths can contribute to key national missions and emerging opportunities with PSA and DRIIV. It will also enable a focused mapping of the Amity University's research capabilities, infrastructure, and innovation ecosystem to address pressing societal challenges. To formally commence today's proceedings, I would like to request Dr. V. Pooja, ma'am, Director and Head, Amity Institute of Biotechnology, to kindly deliver the welcome address for the day. Please, ma'am.
Thank you, Kaushiki. On behalf of our Honorable Founder President, Dr. Ashok K. Chauhan, I extend a very warm welcome to Dr. Amrita Dawn, Chief Innovative Officer, DRIIV, PSA, Mr. Krishan Kumar Gaur, Head Institutional Relation, DRIIV, and Mr. Arvind Iyer, Program Manager, DRIIV, for gracing this occasion. Thank you so much. We understand you're very busy, so thank you for taking time to interact with all of us. I am thankful to Honorable Vice Chancellor, Madam, Additional Pro Vice Chancellor, Dr. Selvamurthy, sir, and all my distinguished colleagues who are here for your presence. Today's meeting is a testimony that we share, Amity University shares a shared vision towards advancing science, innovation, and national development. At Amity, we have always believed that universities are not merely centers of learning, but a powerful engine for nation building. And over the years, it has been more than 20 years now, that we have consciously built a very strong and vibrant research ecosystem, which you would witness in the subsequent presentations that would be given by my worthy colleagues. This commitment towards solving a real-life problem and challenges, and the active participation of our faculty members, our students, and our scientists in areas of critical importance, which is healthcare, environmental sustainability, water security, biotechnology, artificial intelligence, is all a very important part in today's nation building when we are challenged by unprecedented issues like climate change, war, and so many others. Amity's, Amity has believed to extend its length and breadth of our research with this intent. Our focus has consistently been impactful research with absolute tangible societal impact. Our faculty members, scholars are continuously striving to create these solutions, guided by the spirit of excellence, responsibility, and innovation. As India moves ahead to becoming a global leader in science and technology, institutions like Amity University, we see ourselves as crucial partner in this journey, and platform like today's meeting are therefore extremely important, as I said, because we shared this vision of nation building. With these thoughts, I once again extend a very heartfelt welcome to all our distinguished participants. And I'm very sure that today's meeting is going to be extremely impactful, and we would see a very strong outcome at the end of the day. Thank you so much.
Thank you, Pooja ma'am, for the wonderful address. The Office of the Principal Scientific Advisor to the Government of India serves as the apex advisory body to the government, providing strategic guidance on matters related to science, technology, and innovation. It plays a crucial role in shaping national policies, fostering interdisciplinary research, and strengthening the interface between science and governance for evidence-based decision making. DRIIV, the Delhi Research Implementation Innovation Cluster, is a national initiative under the Office of the Principal Scientific Advisor to the Government of India, aligned with the vision of Atmanirbhar Bharat. Established around 2021 and headquartered at IIT Delhi, it serves as the S&T cluster for the Delhi NCR region. Without further ado, I would now like to request Dr. Amrita Dawn ma'am, Chief Innovation Officer, DRIIV, to kindly deliver her address on empowering national missions through research and innovation synergy, Amity University with DRIIV, the Delhi S&T Cluster, Office of PSA, GOI. Please, ma'am.
Please.
Hello, hi. Good morning, esteemed delegates. It's my pleasure and my honor to represent DRIIV, the umbrella body of the Delhi Science and Technology Cluster of the Office of the Principal Scientific Advisor to the Government of India on this esteemed forum. We are overwhelmed by the warm welcome that is extended towards us today. and we are very privileged to present our cluster on behalf of the Office of the Principal Scientific Advisor. So these national science and technology clusters anchored under the Office of the Principal Scientific Advisors were envisioned by the recommendation of Prime Minister's Science, Technology and Innovation Advisory Council. And these clusters are are designed basically to translate regional innovation ecosystem into national engines for impact. Under this network, DRIIV represents the Delhi Science and Technology Cluster, housed in the Indian Institute of Technology, Delhi, under the leadership of the PSA to the GOI. And we are also it's apparent in our name, it's Delhi Research Implementation and Innovation. So we are trying to translate lab-based innovation from research to on-ground impact. So this slide is self-explanatory as we move ahead in our journey of creating an empowering innovation ecosystem of our country. There is no dearth of innovation in our country. What lacks is the acceleration of that innovation. We are too much saturated with high impact innovations, but there is no impact is visible on ground. That's where S&T clusters come into play. So there are 8 such S&T clusters which were established by the PSA office across the country. And Delhi and these clusters are nomenclatured as the city they are based out of, but we are not operationally restricted. So we are actually trying to bridge the gap between siloed research and on-ground impact by converging the industry, academia, government body, and the innovators through leveraging the triple helix model of these 3 innovation, government, India, government, academia, and industry. By impactful collaboration, engaging them in meaningful collaboration, which will make some changes on ground. So this is our mandate. And so while proceeding in our mandate, so these are the key messages that we would like to deliver to all of you today. Is the main activity that we focus on is this bridging this gap. So we are here for seamless transition of lab-based innovation from lab to market. Then of course, S&T cluster is a convergence platform. Otherwise, how else will we be leveraging this triple helix model, right? And then we, through our esteemed knowledge community, we provide validation services because, as our lineage from the PSA office, PSSR is extremely critical in, on validation of the innovation, that on ground impact, that it is actually created an on ground impact moving out of the lab based situations. So our thematic areas are also aligned as per the national priorities for contributing towards Atmanirbhar and Viksit Bharat as envisioned by our Honorable Prime Minister. So we are working under the broader umbrella of environmental sustainability and green energy transition, which includes air pollution mitigation, waste management, industrial decarbonization, e-mobility, green transition, water security, where we deal with water neutrality, urban water body restoration, wastewater management, and providing better service to the public healthcare through application of emerging technologies in healthcare. Our approach is convergence of our ecosystem partners, and we do this by engaging an ecosystem of almost 100 plus members, comprising of leading academic institutions, research institutions, CSIR labs, PSUs, industry leaders, and innovators, along with government agencies, of course. So I'd like to show a brief video here, which will give you some idea about the work.
When I first came to Delhi, I thought I'd change the world with my science. But the world I saw was gasping for breath. And that's how I found DRIIV, the Delhi Science and Technology Cluster. A place where science meets society, where innovation find their ways. At DRIIV, the ecosystem comes alive. At DRIIV, I wasn't alone. There were people building chargers for electric vehicles. Others turning waste into resource. Some designing the next generation of clean air filters. Some rejuvenating water bodies. Together, we weren't just solving problems, we were building possibilities. The first time the numbers dropped, even a little, I knew this was bigger than a project. It was proof that science, when connected to society, breathes life back into the world. From EV charger deployments and smart battery innovations, to sustainable sewage treatment, oil sludge remediation, and next-generation air quality solutions, DRIIV's pilots are turning technology into real-world impact. Everywhere I looked, I saw change in motion. Streamlining public transport, creating predictive platform for pandemic preparedness, indigenous technologies dealing with waste management, establishing EV charging infrastructure in Delhi, pilots co-created with MG Motor and BATX Energies, chargers designed right here in India, and clean technologies being tested for the world. And soon, I wasn't just part of the change. I was helping others become change makers, because innovation isn't just about invention, it's about inspiration. High-level consultations continue to shape strategic collaborations across our initiatives. From one idea in one lab to pilots across states and ministries, DRIIV showed me that innovation is not a moment, it's a movement. The city still has its challenges. But now it also has doers shaped through innovation challenges, CSR efforts, and impactful collaborations, people who know how to build solutions. That's what DRIIV gave me, the power to turn science into hope.
Thank you so much. I have a very talented and dedicated team. So I just shared the storyboarding and they did the rest. So now I'll just give you a snapshot of some of the impactful projects that we are working on or either executed or being executed in near future. So as I have mentioned before, DRIIV is mandated to translate research from innovation to real world impact. So we do this by sourcing problems from industry and government, followed by scouting for solution, from innovators and research organizations, and then validation pilot, and that enables a scale-up deployment through our platform. So these projects are just not a set of initiatives that we are actually, taking forward, but these are the impacts, continuum of the impacts that are being created on ground. From this slide, you can have an idea about the versatility of our platform, and the projects are also totally aligned with various national missions, starting from waste management to National Clean Air Program, Amrut 2, and then National Electric Mobility Mission, so on and so forth. So one of our landmark success has been managing this oily sludge in Oil India subsidiary refinery NRL in the Numaligarh district of Assam, where we have utilized or rather leveraged a startup-led technology on FICO remediation to manage the oily sludge, which this management was 75% faster than the conventional technique that Oil India was taking at that point, with the TPH content well within the CPCP guideline. So first we executed a 100 kg on-ground pilot. The studies, the result were analyzed and validated by DRIIV expert member. This is followed by now an interest from oil to proceed with a scale up of this pilot to manage almost 300 to 400 tons of oil sludge annually. So this is a huge success for us as a convergence platform, where we were successful in bringing together Office of the PSA, Ministry. This was done through MOEFCC. MOFCC, then a leading PSU, and connecting all these dots with the innovator that they were looking for. And now the impact is visible. We are in talks with MOPNG to now introduce this technology to other refineries across the country. So this is how we are also evolving as a national technology accelerator, as envisioned by the Honorable PSSR, Professor Ajay Sood himself. So I think you must be having some dossier from DRIIV. This dossier was launched during our last event by the Executive Director of IOCL, and of course, in the esteemed presence of Vishal sir. So now IOCL has also shown keen interest in adopting this technology. In the plastic waste management front, we are enabling a very advanced and cutting edge technology which deals with integrated catalytic pyrolysis of plastic waste. It will, as a downstream value added product, it will create circular naphtha. And in this project, this is going to be a lighthouse project in India, first of its kind, to produce industry-grade naphtha from plastic pyrolysis. And here we have successfully forged a collaboration between a global leader, which is BASF, the chemical company from Germany, and our innovator, Green Jules and Abhedya, to work together for a proposal for setting up a pilot plant, followed by a commercialization of manufacturing scale. And then proposal is being submitted to RDIF for funding purposes. In the air quality front, DRIIV has successfully executed a multi-stakeholder project which was supported by Google. The project is termed as Project AirView Plus. This project dealt with a deployment of 85 hyperlocal sensors in the city of Gurugram, which actually gave real-time insights on the granular level air quality, which was mostly missing for the authorities to take decisions. So based on this pilot study, now targeted intervention can be taken, and as part of the city-specific action plan taken by Gurugram Authority, smoke gun is now being operationalized in during specific times at the Gurugram city. This project is validated and mentored by our expert in IIT Delhi. Aura Sure is our technology partner, and of course, we have done it with GMDA, Gurugram Metropolitan Development Authority, and HSPCB, Haryana State Pollution Control Board, in with funding support from Google. In the second phase, the same project is now being escalated in other areas of NCR with the support from Airavat Foundation from IIT Kanpur. This is another example where we have helped an innovation from lab to reach scale adoption at an industrial scenario. Here we have this talented startup called Earth, who developed a very innovative filter, which is a retrofit filter to improve the air quality indoor and outdoor. Both this, in this case, we have done this in the indoor. So a pilot was executed with IOCL in the Indian Oil Bhavan to improve their indoor air quality level. Based on the findings, there were almost 48% reduction in the indoor air quality in the IOCL Bhavan. And the administration was extremely delighted for these results. And now they have shared a work order to our innovator for a scale deployment of this product to the entire IOCL Bhavan. Continuing with our clean air initiatives, we have a very nice solution which is known as photobioreactor based air quality improvement. So this product is actually leverages the power of algae to clean the air. So it behaves like a tree. So it's called phyco tree. And this innovation was piloted in GMR New Shakti Bhavan building. And based on the success of their pilot execution, now we are in talks to deploy this solution on road near the T3 terminal of our airport, IGI airport. In the green energy transition front, we are enabling the establishment of a EV corridor by setting up 22 EV charging infrastructure along the Himachal Pradesh National Highway area. Here, DRIIV is facilitating funding support, technical advisory, followed by stakeholder coordination. So this, and also we are exploring the opportunity to tap into PME DRIIV scheme to enable this project. On the other hand, again, I should mention and thank Krishna for this. So I have a very talented team, and this has been an outcome. So we are now very soon going to install EV charging infrastructure in collaboration with Delhi Transport Corporation in one of the bus depots of Delhi, where it will be solarized, and there will be independence of grid storage, and it's going to be a modular structure ideal for urban deployment. Intercluster wise also, the clusters collaborate on a lot of thematic areas based on the expertise and synergies found. We are going to facilitate the setting up of an e-waste management park as announced by the Honorable CM of Delhi in association with the Vizag cluster, who in this case will be the technology provider for the e-waste management We have connected Miranda House, Delhi to our counterpart in Pune for capacity building and innovative plastic waste management technologies. And then also we are partnering with our Chandigarh cluster for scaling up a replicable model of solid waste management, which is campus based. In the wastewater, we are working with Tata Power Delhi Development Limited, TPDDL, to advance their water neutrality endeavors. Here, we have facilitated an water audit certification to them through our cluster partner, TERI. Right now, we are in the process of setting up a sewage treatment plant in many of their sites in West and North Delhi, followed by water recharge. We will be doing all this through our innovation ecosystem that are working, that we have created as a community. Again, in the wastewater management front, we are working with GMR to reduce the hardness of industrial water, which is the cooling tower water hardness, for increasing their reusability by using an innovative triox-based oxidation and microalgal bioremediation method. We are also in the process of rejuvenating 5 water bodies in the Gurugram region, and also, proposals were submitted to Delhi Jal Board for restoration of various lakes in Delhi. These are all done through support from our CSR partners. So these are, as DRIIV move on to the second phase of our activities and execution, I'd like to share with you our successes, which actually helped us propel our journey towards this far. And so these are what we have done so far in the green energy and clean mobility field. We have set up a lot of EV charging stations in the MCD parking lots. Pilots are ongoing on e-mobility utilizing second generation batteries. And we also are advancing with graphene based battery energy storage, as well as solar coating to improve the efficiency of old as well as new solar panels. So we have so far commercialized 4 technologies for leading CSIR labs. So these deals with all these areas. It's visible on the screen. We are providing validation as a service to our innovators and also our research personnel. And of course, we offer our platform for engagement in various multi-stakeholder impactful collaboration. These are some of our CSR endeavors. We have in the video, it was shown that we executed a pilot on clean air with Delhi Pollution Control Board, where we piloted 14 startup-led technologies for a period of 6 months to improve the air quality of Delhi NCR. Then we have established an AI-enabled infectious disease platform. Our COVID-based platform has already been adopted by ICMR. With Daphne, we are working on effects of air pollution on pregnant women and newborns. And for similar kind of hyperlocal monitoring, as I have already explained for the Gurugram region, is being done in Calcutta as well through our CSR partner, Environmental Defense Fund. These are, some CSR initiatives on plastic waste management, empowering the community through awareness, capacity building, as well as with resources. We also successfully mobilize corporate capital into sustainability. For this, we partner with various industry leaders working in the field of sustainability to run joint innovation challenges or hackathon on tailored problems sourced from the industry and the government bodies. And then funding supports are also available for these programs. One of our innovators have received a funding of 1.2 CR to set up an R&D lab from Titan Design Impact Awards. So these are some of the capacity building so the latest one that we executed was the Samavesha one, where, some esteemed delegation from Amity also participated. But this is our regular affair based on the interest and queries we receive. We carry out capacity building, engaging our ecosystem partners. We are also taking strides in creating quality knowledge resources in the form of white papers, compendia, reports. These reports are mainly launched by the Honorable PSSR in various of our meetings, and these are also available on the PSA website. And we very recently also we have carried out a roundtable event on targeted cleaning of Yamuna by involving experts from all across the country, based on which we have published a white paper on this 22-kilometer cleaning of this Yamuna river. Very recently, we have signed an agreement with University of Western Australia, where DRIIV's focus area will be environmental sustainability, climate resilience, and of course, healthcare. So the outcome is to strengthening global talent, and they have shown keen interest in, coming up with initiatives like joint fellowship, research, and innovation challenges, studentship, and also postgraduate scholarships. They also run hackathons bi-yearly. So these are all new developments that are happening in the cluster. So we annually have our flagship conference where we share the stage with our innovators to showcase their technologies. This is Mashal Green Fellowship Award, which we celebrated with two of our Green Fellows who are the winners of this award. 5 lakhs each were granted, and this support was extended very kindly by our industry partner M3M Foundation to work or to empower the environmental sustainability research area. Last year, we had our international conference of the S&T clusters, which was chaired by the PSSR himself, and there was a participation of almost 30 countries from across the globe. Here also, there was a pavilion of DRIIV where we have given opportunities to our innovators and research community to showcase their innovation. We have also exchanged MOUs on environmental sustainability, plastic pyrolysis with BASF, and with WebCost Limited to work in developing, AI-enabled infrastructure, so on and so forth. And this is the Samavesha event, which we organized in coordination with IIT Delhi and iSTEM under the aegis of the Principal Scientific Advisor's Office. And last but not the least, so we just had our conference where we celebrated us becoming a national technology accelerator. And we also launched the dossier of DRIIV. The event was graced by from our former Joint Secretary of DPIIT, Shri Sanjeev Singh ji. And also there were esteemed presence of MD from Oil India, NRL, ED from IOCL. Vishal sir, of course, is a pillar of strength for all our activities. And again, high visibility showcasing platform was there. So this is for you. And these are the scopes of engagement that I envision that we can carry forward with the Amity ecosystem. I have tailored this as per the need for the faculty, academicians, for the students, and for the universities as a whole. So that's all from my side. I would happy to address any questions from the side.
Thank you so much, Amrita ma'am, for such a wonderful and a detailed presentation on the DRIIV cluster. Before we proceed to a detailed presentation on Amity University Noida's strengths, I would like to humbly request Mr. Krishan Kumar sir to please share a few remarks on the session today, please.
Thank you and good morning all. It was a last minute arrangement, but okay. Amrita has covered each and every aspects of the drive and the functioning of the Office of PSA. Since Office of PSA is primarily involved in, as an apex body which advises the PM and the cabinet on science and technological affairs, drive is more focused on identifying the various technologies across the world, particularly in India, and giving them a lab to scale kind of a thing. Apart from this, we are also working with the various government department to work on the convergence of the schemes. So then, Skill India Mission, Make in India Mission kind of things, we are also trying to converge that. And if MET feel we can have a dedicated skill development center first. Secondly, we can also identify the possible incubation center so that we can identify the natural kind of entrepreneurs, kind of innovations coming from the MIT, and then they can go to the larger level. The rest, I think, everything has been covered. Thank you again. Thank you.
Thank you, Krishna sir, for your words. Dr. Chandradeep Tandon sir, Additional Pro Vice Chancellor, Amity University Noida, is a seasoned academic researcher with over 16 years of experience with an illustrious background in teaching and biotechnology research. His expertise spans proteomics, medical biotech. With 59 publications and 7 research projects to his credit, he has been very instrumental in academic planning, curriculum development, and fostering research collaborations. May I humbly request Dr. Chandradeep Tandon sir to deliver a detailed presentation on Amity University's R&D ecosystem and its achievements. Please.
A very good morning to everyone. On the behalf of most respected Honorable Founder President, sir, Honorable Chancellor, sir, respected Vice Chancellor, Madam, Dr. Silla Murthy ji, Additional Pro Vice Chancellor, Dean, all present here on our own behalf, I very warmly welcome once again Dr. Amrita Dawn. You gave a very nice, very informative information for all of us. And Mr. Krishan Kumar Gaurji, thank you so much for being with us. Dr. Vishal Chaudhary ji is held up due to some very important urgent meeting, and we are looking forward to seeing him with us soon. It's not moving. Okay, so I'll simply giving you a glimpse of the research R&D ecosystem of Amity University. Yeah. At MIT University, this is our tagline, we always nurture talent, national building through education and research. So here is our leadership, our trustees, Honorable Founder President Sir Dr. Ashok Chauhan, our Chancellor Dr. Atul Chauhan, who is also President of RBF, and Dr. Aseem Chauhan, Regional President RBF, Mr. Ajit Chauhan, Vice President of MIT Online Distance Education, Mr. Abhay Chauhan, Senior Vice President RBF, and Mr. Amol Chauhan, Executive Director, Strategic Operations, MIT University. MIT University, as you can see from this data, it is the largest education and research group, and it has 6,000 alumni across the world. 6 lakh, sorry, 6 lakh, pardon me for that. 2,50,000 most brilliant students, 6,000 faculty and scientists. We have 12 universities and 14 campuses. We have overseas campuses. I shall be showing you a glimpse of that soon. We have 28 schools and preschools. And you can see we have 150 plus institutions, 400 programs covering 60 disciplines. And we have been ranked #1 not-for-profit private university. These are the various campuses in India, and currently we are in Noida. We have various campuses across all the states: Jaipur, Gwalior, Mumbai, Bengaluru, Raipur, Kolkata, Ranchi, to name a few. We have established a worldwide presence. We have MIT campuses in Singapore, Mauritius, MIT New York, Nairobi, Tashkent, London, Dubai. We also have MIT schools. I just learned from Dr. Amrita Dawn that her kids are studying in MIT Saket. They are in class 7th, and both are twins, a boy and a girl. Am I right? Yeah. So it's a small world. So welcome to MIT University once again. So these are our schools. We also established Harrow MIT partnership schools in New York and Bengaluru. We have a campus in MIT University, Long Island in New York, which is MIT Global Research Hub, where we cater to Indian system of medicine, various niche areas of research. This is about our rankings. MIT has been ranked as per NRF, ranking is 22, for pharmacy 18, management 49, engineering 37, agriculture we recently started, which is headed by our brilliant scientist, Dr. Nutan Kaushik ji. She is here with us. We have a ranking of 15 for the first time when we applied. So these are the programs which are being offered in MIT University. You can see, you name it and we have it. It starts from advanced material technology, applied sciences, biotechnology. I'm just reading few of them. This is a whole gamut of programs right in front of you. Molecular medicine, stem cell research, nanotechnology, herbal research, geoinformatics, forensic science, occupational therapy, neuropsychology, neurosciences. And we have UG, PG programs and also PhD programs. These are our MIT research enablers. We have very robust IPR protection cell. We have Director of Innovation and Technology Transfer, MIT Center for Entrepreneurship Development. We have EDC cell, E-cell, Entrepreneurship cell, of course, FSTIA. And we all our warriors, SNT warriors are here. We have STIF, led by our respected Dr. Silamurthy ji, who is here with us, and ETSI, MIT Director of Science and Director of Science and Innovation. This is about our research publication and H-index. Currently, we have an H-index of 202. You can see the number of publications are climbing. And by God's grace, the day is not far, then we will have a very high H-index. And we have publications which are of high impact factor, Q1, Q2, and also Scopus indexed. This is about our patents. MIT University has filed more than 2,000 patents, and the number of granted patents are 450. And here also you can see with the passage of time, right from 2008 till 2026, the number has gradually increased, and all our brilliant scientists, our PhD scholars, and even UG, PG students are equally involved in this. These are our various missions, mission outcome. Our founder president's vision is that whatever we do here, whether it's a conference or it's a workshop or any kind of deliberation, scientific deliberation we do here, it should definitely have a meaningful outcome. So we have a mission connect and synergy. We have mission knowledge to wealth. We have a quantum mission recently launched. We also have mission space and mission green hydrogen. These are the senior researchers and young, we also have senior research and young vibrant brains working seamlessly. As you can see, Nobel laureates also visited here, Sir Richard J. Roberts, Kailash Satyarthi, and Professor Harry Kuroto, Professor Werner Arber, Professor Yuan T. Lee. We also have a good number of Ramalinga Swami Fellows, Ramanujan Fellows, DHR Fellows, Wellcome Trust and BioCare Fellows. This is our human capital. We have brilliant scientists, which cuts across all the fields. I showed you a list of programs, and it's not only UG and PG programs. We also have brilliant researchers across all the disciplines. This is a quick glimpse of all of them, rather few of them. So this we have Ramalinga Swami Re-entry and Ramanujan Fellows. We are proud to have maximum number of, rather the largest number of fellows, I guess, across all the private universities. Coming to our research infrastructure, we have very robust infrastructure. We have state-of-the-art equipment. Here is a glimpse of few of them: confocal microscope, fermenter, gel dock system, scanning electron microscope, fax, X-ray diffractometer, gas chromatograph, and we recently acquired NMR 400 megahertz. These are the other facilities, research facilities of MIT University. We have all the instruments which are possible, which enable us to produce good results, to produce good publications, patents, and also commercializations. We have a very important MIT Center for Artificial Intelligence, which is led by Dr. M.K. Datta, who's sitting here with us. We have NVIDIA system with 10 petaflops computing power. And AI is such an important field that cuts across all the disciplines. And we have not only at PhD level, we also have very good research papers, publications of high impact factor, where our UG students and PG students very actively participate in that. Okay, I would definitely like to bring to your attention a very important MIT BioNist. Recently, we have been, Krishan Kumarji and Dr. Amrita Adon, we have been, granted a very prestigious MIT BioNest by DBT BioRec, worth 6 crores. And the focus areas are health and biopharma, agro and food technology, environmental sustainability and climate. In fact, all the areas of the cluster which we are, which our coordinators, our scientists are presenting, are covered in here. So this will be for 3 years, and the target is creation of successful startups with execution and development of self-reliant model, targeting contribution to self-reliant India moving towards Viksit Bharat. So this was there was a cutthroat competition, and all our scientists put our heads together under the mentorship of our Honorable Vice Chancellor, Dr. Vrinder Shukla ji. We also have Nuclear Security State-of-Art Laboratory. It's a DRIIV-funded project. This is our research infrastructure, which also will be catering to the MIT BioNest, which have recently got. We have all the incubation facilities. We have MIT Innovation Incubator with us. These are some of the other facilities. This is NMR facility, which I earlier showed you also. This is Agri Photovoltaics, and Dr. V.K. Jain is here with us. He is the person behind it, very amply experienced person. And we can see here, this combines solar photovoltaic panels and agriculture for optimizing land use, generate electricity, additional source of income, enhancing the efficiency of solar cells. We have DST supported MIT Innovation Incubator, which I just spoke 2 slides back. And the companies incubated are 750 plus, employment generated 6,000 plus. We have international collaborations. We are startup by faculty and students also. And the target for the next year is to generate 15-20% equity in 1,000 companies. So these are our, graduated incubatees, resident incubatees, a glimpse of that, and virtual incubatees. We have startup ecosystem, and you can see the investment raised are to the tune of $40 million, 700 plus ventures, employments granted, 70 plus companies established by MIT students. This is again about the biomass facilities, which we already have. We have Directorate of Innovation and Technology Transfer, and by which has successfully been transferring all our technologies where our scientists have been working and researching on. To name a few, we have Rotonic, it's a plant growth promoter. It's a stress tolerance biofertilizer, and Dr. Amit Khadakwal, he's the one person behind it, along with late Dr. Ajit Verma ji, who have worked very hard for that. We have Agrivoltaics. We have Pebbles based on green technology developed by Dr. V.K. Jain. And similarly, we have lots of technologies which are being transferred, successfully transferred. These are the awards for excellence. The top Indian academic institutions for patent commercialization we got in 2020. MIT University was also conferred with the CI Industry Intellectual Property Award 2023. This is recently we got at the SOCHAM 4th IP Excellence Award. This is the award for excellence again as one of the top copyright filters in the country by the Office of Controller General of Patents. This was bestowed on us on 4th of June 2025. And we also make a difference when it comes to humanitarian acts. This MIT Humanity Foundation, education of the underprivileged children, women empowerment, livelihood, generation, and community. Our Honorable Founder President, sir, is a great philanthropist, so which is evidenced by this particular foundation also. This is the one, recently there was a meeting of our all trustees, our Honorable Founder President, sir, Chancellor, sir, Dr. Aseem Chauhan ji, with the PSA, Dr. Ajay Suji, and Dr. Silamurthy ji was also there with us at that point of time. Thank you so much.
Thank you, sir, for the detailed presentation. As we all know that the DRIIV's focus areas are environmental sustainability, water security, green energy, and the digital healthcare, which align with the national priorities and the research trends of institutions all across India. Aligning with these thematic areas of the DRIIV, there will be now dedicated presentations which will be delivered by each respective coordinator of the thematic areas. Firstly, I would now like to request Dr. Nutan Kaushik ma'am to deliver her presentation on the theme Environmental, Water and Food Security area. Ma'am, please.
Thank you. A very good morning to all of you. So, I'll be presenting a brief glimpses of Amity's strength in environmental, water, and food security, as mentioned by Dr. Tandon. In environmental, food, and water security, Amity has been working in these areas. One is the sustainable agriculture, biofuel, circular economy, bioremediation, waste and wastewater treatment, and climate change. So these are our main focus area. Apart from that, we are working on other aspects also, but these are our main focus areas. So these areas are very much aligned with the national priorities. So if we go by the thematic area itself, it's so they are aligned with Viksit Bharat 2047 vision. They're also aligned with the Atmanirbhar Bharat, and they are aligned with the relevant national missions initiative. So this like Jal Jeevan Mission, National Water Mission, National Food Security Mission, PMSKY, these are some of the missions which are aligned with this the whole thematic area. And for each focus area also, we have aligned with different sustainable agriculture. So at Amity, we have this culture that whatever we do, it should align with the national priorities. So all our research initiatives or our research focuses on the national missions. So now coming to the technical strength and the research progress, I would like sector-wise thematic area, each focus areas. So in the agri and food technology, as Dr. Tandon mentioned, we have been ranked number 15th in NIRF ranking last year. And Amity is active in agri and food sector since its inception. There are very few private universities who had the agriculture right from the beginning. Recently, we have many universities which have come up with the agriculture as a focus area. But MIT, since its beginning, has agriculture as a dedicated research center, and also the academics. So we have implemented more than 40 projects, including 10 international projects, worth 18 crores in agri-food domain. We have developed many technologies. Dr. Tandon mentioned few of them, which have also been transferred. And prominent among them are the Rutonic, which is developed by late Professor Ajit Verma ji. Dr. Amit Kharagwal is taking that forward. Legacy forward. Then HB9 developed by Dr. Amit Kharagwal, NKIT19 developed by myself, and then zinc oxide nanoparticles, agri photovoltaic, Dr. Jain is sitting here, biopesticide, biofertilizer, ZECC is zero energy cool chamber, is a low energy for the marginal farmers, cool bot, herbal mosquito repellents, protein hydrolysates, functional foods, pickles, and so on. So the government has published more than 600 papers, have filed more than 50 patents, and 24 are granted. And seven technology transfer has been done. I hope focusing mainly on 3 technologies, but 7 technology transfer has been done. We have 15 active MOUs just dedicatedly working in this domain. And then more than 50 PhD scholars are currently working, like targeting solving different problems aligned with our national missions. More than 300 master's students during the master's, we have the NTCC called 6 months thesis project. Those thesis projects are also aligned with our national missions. So, and then we conducted more than 50 training programs and workshops, and we work very closely with the farmers also. We do a lot of extension activities, and whatever we develop, or is already developed by someone else, we take it to the farmers, to the end user. So like for others, the industry is the end user, but for us in agriculture, farmer is the end user. So we take whatever we develop to the farmers. And then we are mentored by the world experts like Padam Shri Professor Ratan Lal. They're all our honorary doctorate or honorary professors who are mentoring our faculty apart from our own faculty. Professor Dr. Purvi Mehta, you mentioned about the UWA. Professor Kadambok Siddiqui is from the UWA, and we have successfully done a lot of projects with him. And our students has done the internships and has availed the internships. So we did this climate smart agriculture practices project with him. We will be very happy to discuss that with you because you mentioned that you have MOU with the UWA. And then Professor Viva Srivastava from Arkansas University, Dr. Muniappan from Virginia Tech University, and Professor Randy from Michigan State University, Professor Rajiv Varshney, who is a world-renowned authority now in genome engineering. Now he's in Murdoch University. They're all senior people, senior professors who are mentoring us. And Now, artificial intelligence, we cannot evade because it's a era of AI. So in agri-food domain also, we are working on crop disease detection management, crop yield predictions, and soil health assessment. Now there's a concept of One Health, and soil health is very important in One Health. Now, in coming to the environmental security, we have been working in environmental toxicology, environmental chemistry, environmental biotechnology, air pollution. You mentioned about the air pollution. You are working with TERI in the air pollution. I was also working in TERI before joining here. So I worked there for 24 years, and I was part of the source apportionment study which they did for the air pollution. And so air pollution impact on health and vehicular pollution. MIT is also strongly, Dr. Renu Dhupar is sitting here. She is working there, her area, her whole institute is working in that area. Ozone and impact on crop production and marine litter, and then soil and water pollution studies, and extremophiles microbes from biodegradation from Antarctic. MIT has a presence in Antarctic through in the environmental sciences. So we have a station. We are the one. We are like as Dr. Silvamurthy always said that we are present in all the continents, including Antarctic. So environmental sciences has established a center in the Antarctic and in southern oceans. And then EMF radiation studies and biological correlations. There was a study done how much radiation is impacting the human health, and this has been like documented very well. And it was used. AI was used to the data which was produced through the radiations data which was produced. And then algal biofuel and nanomaterial. Dr. Archana and Dr. Manoranjan is not here. They are working actively on this algal biofuel. You mentioned about the algal clean air, and we are also in the civil and wastewater treatment, and we are equally working on the same area. I will be presenting few technologies which we have developed. Then expertise in isolation mass cultivation diatom, Dr. Archana is doing that. Then we have established protocol for the wastewater and resisting. And we have, I will now in the bioremediation, we have the fungal stains which has been used. It has been isolated from the decade. Dr. Shashi is sitting here. That enzyme, so enzyme profiling and identification conditions for maximum degradation has been done. Then it is highly efficient and reproducible in lab conditions. Presently, it is in TRL3 level. So these are the relevant infrastructure in agri-food domain and environmental. This I'm not talking about the entire MIT. MIT has huge, which Dr. Tandon has already presented. So these are in our, we have molecular biology, all what you name it and we have it. So some of the pictures, GCMS, HPLC, plant growth room, and then we have food processing pilot plant also, and then atomic absorption ripening chamber. Ripening chamber are normally not present in any of the university. We are the one, we have a center of excellence on post-harvest technology and cold chain management. That's why we have these facilities here. And then technologies which are developed and transferred to the industries. So this is in some glimpses. So we have like patents, we have 14 technology has been transferred, and number of projects 45, MOUs 25, and you can see this peace solubilizing biofertilizer. Then we have biopesticide from BCMNCs. We have Rootonic, which has been developed by Professor Ajit Burma. We have rice husk cellulose, egg cubes, you name it. And we we also use the waste utilization, but develop the product from the waste. I will be dedicatedly presenting a separate slide on this one. So these are the technology which has been developed in the area of biopesticide, biofertilizer, PGPS, and biostimulants. So this is the Rootonic. The first one is Rootonic, which is Piriformis indica. Dr. Karagbal would be able to answer your questions related to this technology. Then HNB9 is also from Dr. Avid Karagbal. This is a biofertilizer and biopesticide altogether. Then NKIT19 BCMensis from my lab. And this has antifungal phosphorus solubilization and PGPR activity. And then we have biosurfactant from Dr. Shashi's lab, which is also stimulating the plant growth and is enhancing the plant growth. So these are, and out of these four, 3 has been transferred to the industry already. And this Rootonic has been transferred to multiple industries, including the one in Taiwan. And these are the bioremediation related technologies which we have. So we have Aspergillus auricus, which has been developed a biosurfactant and which can be used. And then we have 3 organisms which are responsible, which are being used for different bioremediation purposes, like those for liquid waste management, BPA and TCS, the recovery of the rhamnoleptides, and then hydrocarbon degradation. Yeah. You mentioned about this oil decontamination, and these are one of the technologies is also being utilized by them. So this is the forward osmosis membrane system for cleaning the water. So this has been developed by environmental science. Dr. Manoj is sitting here. And then this is how it has been used. And this has also been improved version by incorporating this graphene quantum dots. And so then microalgal biorefinery platform, we have this Dr. Manoranjan is here, and who is working on this utilization of the like all the biomolecules which are present inside the algal cell, be it lipid, be it gluten, be it carbohydrate or the protein. So entire it's a kind of circular economy kind of model. So they are working on utilization of each and everything, at the same time treating the wastewater. So the same algal is being used for treating the wastewater, and they have developed different products out of it. And then diatom, Dr. Archana is here, is being used for the wastewater equally. We have got a project from industry for treating the wastewater, and then it has a biodiesel quality. It can remediate the wastewater. It has bioactive compound productions and so on. And then coming to the waste, in the waste, we are also working on the floral waste. And this could be one of the project which can be a societal project. Like we have a lot of temple forest, the floral waste coming from the temples, and this can be tackled by we have developed the manure out of it. So this by composting it. Then another one is the nitrogen fortified biochar. Dr. Manish is sitting here. He is working on the biochar, and biochar is application is in all fields: agriculture, environment, water purification, and everything. And then the third one, which we is showing, is the like conversion of the fish waste into value-added products like protein hydrolysate, and then the what you call this gelatin and so on. So this fish waste can also be a kind of a societal project where the fish market waste can be converted into a value-added product. And then publication patents, I will just run through. I think there's no need of going through these publications. And then these are the proposed plan and impact to the society. For sustainable agriculture, we want to take this, validate this up to the industrial scale, and then that from TRL 429, and then expected expected delivery, wider adoption at Delhi and NCR and National Agriculture System, integration to government-supported natural farming. So these are the expected impacts. Then for bioremediation, we want to conduct the pilot scale and industrial effluent and municipal waste setting, and integration with waste management. For floral waste, again, I have already discussed. We can discuss this during the lunchtime or these things. So now, you know, in nanoparticles, we can scale up for the biogenic nanoparticles for commercial biofertilizer production and so on. So for diatom also the similar things, and microalgal biorefinery also. So these are the expected impact: environmental impact, agriculture impact, sustainability, and socio-economic impact. Thank you so much I'm sorry for taking much time.
Thank you, ma'am. I would now like to request Dr. Kamal Rawal, sir, Professor
So
Biotech.
I would
Yes, yes, ma'am, please.
yeah. So I'd just like to mention one point here. So thank you for, sharing all the information. And I think smart agriculture, Delhi cluster is not directly involved in that thematic area, but I would love to connect you with our counterpart in Chandigarh. So they have a dedicated thematic area in the smart agriculture. For the fish waste thing, I think there might be an use case for us. So Arvind, that WSAFE a proposal. So I would like to have the use cases that you have defined for your research outcomes. If you can share that, then we will go through it and see. Also, as looking for some plastic waste management technology, if you are having that, will be really nice for me to look at.
Thank you, ma'am. I would now like to request Dr. Kamal Rawal, sir, Professor Amity Institute of Biotechnology, to deliver the presentation on AI in healthcare.
Good afternoon, everyone. So I'll be basically, taking up some of the use cases to showcase MET's strengths, how we are using AI in transforming healthcare, and how several projects have actually made an impact in, building some of the or solving some of the important healthcare problems. Now, in order to have a stronger and developed nation, the health is a vital component. And India is facing several challenges in healthcare domain. One is we're having a lot of infectious disease load. Secondly, as we are progressing, we are also having increased loads of obesity, diabetes, and cardiovascular and cancer load, which is coming up in the population-wide surveys. And there are shortage of trained medical professionals. Then a lot of expenditure is spent by the people on their healthcare needs in hospitals. Because of that, they are not covered with insurance. So there's a lot of load on middle class and lower middle class people in India. So there's a urgent need for affordable, scalable, and accessible healthcare solution. So what is our response in that direction? So we have actually built an ecosystem to solve or to counter that kind of problems. First, we have right kind of people who are working in interdisciplinary areas, which includes AI, healthcare, biotech, bioinformatics, and clinical research. Secondly, we have established right kind of a computing infrastructure, which Dr. Tandon has also already shown. Then we are acquiring or collaborating with right kind of a people to get right clinical and population-wide data sets. And we have established a lot of collaboration, important linkages with right hospitals, people who are working in our field to solve that particular problem. While doing that, we have published a lot in high impact journals. Our papers are getting cited. And we are also securing the critical mass of getting right funds from DBT, DST, even the international funding agencies also. So this is the summarized versions, what I just discussed. We have dedicated center for MET Center for AI, which a part of that center is devoted to work in healthcare problems. We have supercomputing infra. We have specialized faculty groups which are collaborating with each other. And we have acquired large-scale data sets. And how we are, this slide basically summarizes how different projects, different tools, which can be correlated with national priority areas, which includes One Health, NCDs, maternal and child health, and tribal health also. On right-hand side, last column, you can see the various projects which are continuing in the system, right from vaccine development, ECG classification, thalassemia screening. So these projects can be mapped to the national priorities, where we are looking forward, where we can establish, scale up projects or pilot projects with the right people. So these are the some of the strengths I would like to showcase. These are some of the important platforms and tools which have been developed and deployed. First is in the vaccine development, it cuts down the cost of vaccine development. It speeds up the vaccine development process. This has been used by scientists from various countries, and our collaborator with Baylor College of Medicine has actually used for getting new vaccine candidate in phase 1 and phase 2 trials. Hookworm vaccine and COVID, so it is being actively used by those people. And now we are getting into, talking to Harvard Medical School and pharma companies to take this, applications to a new areas also. Similarly, we worked with, for lung cancer situation, so we worked with Pfizer. There's a pharma giant for early diagnosis of lung cancer, where we were collaborating with one of the leading hospital in Delhi, Rajiv Gandhi Cancer Institute. So our system was developed, deployed with them, which can help to diagnose lung cancer at early stages. and also help what we call radiogenomics. Based upon the tumor characteristics, we can understand what mutation that tumor would be carrying, that patient would be carrying, and the right prescription can be given. So again, we are looking for partners in hospitals or people who can, help to scale up this solution. And then Dr. Datta's, who's sitting next to you, has developed breast cancer detection for MRI. And then we have retinal, eye disease related vision deep AI. Dr. Manoj Garg, Dr. Priyanka Jain has developed deep learning based system for which are prognostic markers in breast cancer for identifying them. Then Dr. Abhishek has developed a fertility predictor which has been used by IVF centers, and again it's a commercialization stage, and it is, they are trying to take it to the market. So this is how a generic clinical translation pipeline looks like, which runs through, it's kind of a theme. We acquire data sets from clinical imaging and all. We build AI models. We do validations in India as well as with data set coming from abroad. We develop deployable tools, and then we take these tools to make impact, which includes early diagnosis, reduction of cost, scalable screening, and precision treatment. So that is a generic theme which we are following. And again, okay, yeah, sorry. So again, this is a detail of what I've just discussed. So under cancer, we have number of tools which have reached to a clinical grade FDA approved accuracy levels, which can be taken further. Under genomics and oncology, we have systems, a lot of papers and projects. This is a vaccine platform, which I've just mentioned. And now I would like to showcase how research, so how a seed money, which was given by some US agency, and then we, carried forward, we built upon that, acquired more grants. That platform was actually reaching to a startup stage. And this is the timeline, these are the papers. And for past 5 years, we've been working relentlessly, and we are now building up what we call precision AI. From generic AI, generative AI, we are reaching to a new kind of a precision AI based systems. Dr. Abhishek just mentioned, he's working actively to take his fertility predictor in various areas of reproductive systems also. Even mental health, he has started working. Dr. DRIIV does her work, take AI to for a population and public health screening, how to take this solution to a scale. Similarly, these are the other solutions. For digital health and hospital systems, we have apps, IoT systems, platforms developed by our public health institution. These are the notable publications in various reputed journals. These are the funding supports, and we have extensive research collaboration from leaders in the hospital and medical domain. The idea is to make a impact to the real world healthcare use. And these are the, some of the important challenges which our solutions are addressing. First, we are reducing the need for expensive biopsy, reducing the pain for the patients. Second, we are also addressing if there are no radiologists in rural area, because this is so we have systems to, we have platforms to help in this situation. There's a global problem, vaccine development, which is slow, which is costly. So we have solution for that. For tuberculosis, drug adherence and resistance, we have a therapy system, personalized TB therapy system. And we, in order to address India-specific cancer data set, we are actually working on building such kind of data sets. Thank you very much.
Thank you for that presentation. Actually, DRIIV is building our phase 2 vertical on AI and ML for public health care. And the cluster will be very happy to collaborate with you. And very soon we will be conducting a roundtable to initiate the discussion of our third vertical. You will be intimated to participate in the collaboration. I have one more specific question. Are you currently associated with any hospitals? Do you have any current ongoing project? Okay. AIM Delhi. Okay. 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 So please let us know how the cluster can be involved in these projects, because I think this One Health mission is also a brainchild of the current PSSR. And as part of our third vertical, we would love to take some of the initiatives forward jointly. So AIMS is an ecosystem partner of DRIIV. So with AIMS, previously we have worked in finding out the air pollution effect on human health. So that we were associated with the community medicine department professor, but we can definitely explore further opportunities, and DRIIV would love to have. So what is the TRL level, highest TRL level of product that you have?
One of the the product that I have developed in my lab,
And then
it has reached to TRL 8, and
Okay.
it is now in the market by one of the company APS Technologies from Pune, along
Okay.
with the PCR kit for Y chromosome microdeletion
Okay.
identification for male infertility.
Okay, so this is the fertility thing.
Yeah, so it is it is in the market now,
Okay.
and it is being used by all the clinicians and the IVF clinics for identifying the male infertility, this particular disorder.
Okay, I think your highest whatever solutions or products that you have, which have reached the highest TRL level, it can be showcased on our portal also. And I think Krishna, so he is not here. So I think your fertility product will also carry a lot of impact, rather, interest in the CSR field, because we do have a lot of CSR partners, and their thematic areas does align with the healthcare. So, we would love to initiate a discussion.
Dr. Amrita, let me supplement what my colleagues have said. AI application in health, Amity has got tremendous contributions, significant contribution. Then you asked a question that do you work with hospital? We have MOU with 15 hospitals, both in government sector as well as with the private sector. Then we have an MOU with ICMR, Indian Council of Medical Research. So we work with all ICMR institutions. So we have a very strong connect with all stakeholders in the health sector. But Dr. Datta, MK Datta, he has done a lot of research in the UP government, also in health application, cancer cervix, how do you diagnose it? And then using biomarkers. So I would request him to say a few words, then I will give some more remarks.
Okay, so thank you. Particularly, I am a core AI scientist. You can say I'm a mathematician. I'm not a healthcare person, but because AI is an abused word these days, everybody is almost everybody is an AI scientist. So yeah, but I'm mainly a mathematician. You can say. But you see, when you understand, in our center, in our AI, in this one of the rare universities where actually we are going to the core. AI is all about training weights. It's the maths that you understand. Very few people can actually understand. They're randomly using some tokens or some, pipeline. So this is what we are doing. Our students have that competency where they actually understand to get inside a model and understand how the weights are being trained. And without understanding this, you'll always be dependent on Geminis and some GPTs and Llama 3s and all. But here the idea is you understand how this is number one. Number two, and this is the context of healthcare. So I'm personally have done a lot of work For example, right now we are working, if you can show here, I can show you. We are working with you know, the VRDL database. There's a VRDL database. Anyone aware of it? Like VRDL database is a 150 collection center across the country. So we have an access to around 65 million subject database. Yeah, and that's collaborating with ICMR Chennai, National Institute of Epidemiology. So we are making a virus diagnostics where I think you're visiting our lab. I'll show it to you here. So one single click, you know, with some symptoms, will tell you what is the confidence score of the virus. Because see, chikungunya, dengue, influenza, they have similar symptoms, and sometimes they recommend multiple tests. So we are nullifying that. This is at a big scale. It's a big project that we are doing, and many more like gallbladder carcinoma. Almost all cancer. See, the point is some of the interesting things that we have done. For example, let's talk about cervical cancer. Now, cervical cancer actually goes for pap smear. You know, it's a costly business testing. You know, in India and rural in tier 2, tier 3 cities, we have done biomarker-based studies. Papers are published. Apps are ready. When you come to the lab, I'll show you. It's like do a blood test, 150, 200 rupees. Get some biomarkers done. Your demographics, like some age and some questions they're going to ask you, and the blood values, it'll return with your confidence score. How close are you to cervical cancer? The data was collected from King George Medical. I was in a very senior position in Uttar Pradesh government, so I very closely collaborate with King George Medical University, SGPGI Lucknow, AIMS Delhi, many more. I mean that Kalyan Singh Cancer Institute is a very close friend, the director. So I have access to a lot of data. When you come to our lab, I'll show you actually the running apps. And you can appreciate, if you can show you here, I can show you, or it's online. Everything is online. And also, if I have a minute, I'll show you something about our students, because we're very proud of our students, what they do. Can you, do you have it? Can you open a browser? एक browser खोल लिखिए इसमें amity.edu amity.edu/ACAI हाँ इसको खोलिए. Go to that research, student innovation, click this. Yeah, come down. See, this is our lab. One sec, hold it. This is our lab, and you come down, scroll down, please. You'll see a lot of student. Okay, let's go to the first one. Okay, let's go to the Susan receipt. Click. You have a pop-up there. You have information about the student. Okay, this is one of our student who was working with that. Chandan Das, I think, yeah, Chandan. No, this is a spine. So you can see we're working on. This is already a published paper on lumbar spine MRI localization, and if it is of interest, can you close this? I'll show something. RGT transformer. नीचे आइए. Scroll down. See, Gautam Verma को click करिए. No, this is purely mental health, EEG signal, 36 cap channel, and this is related to repression detection. And you can see the model that has been used is an attention-based model, which is a very advanced model. It's not just like putting a CNN or a RNN, putting something like that. So, and this is published in IEEE Transaction, which is very prestigious for any engineering or electrical engineering. Close this, please. Close this. View all projects mein kariye. So you will see a number of our student projects which are here. Anything can you click anything like something related to healthcare? नहीं, ये healthcare नहीं है, ये healthcare नहीं है. इसमें cancer. Okay, so yeah, this is breast cancer. So you can see this paper was very recently. So graph neural network we have used. So ma'am, when you come to our lab, I'll show you the running apps. On everything that you see over here, there's an app which is deployed either in Streamlit or in Netify, somewhere it is done, and we can show you. I mean, they are actually ready for deployment, and many of them are deployed. And we work with, see, every work has a collaborator, either AIMS Delhi or, that ICMR, NIE or ICM. We are working with DRIIV, that is your bacterial infections in Kolkata. The director is a very close friend of mine. So there we are working with pharmacokinetics, the blood absorption, how much, when you give a drug for a tuberculosis, how much it is absorbed. And the PINN has come up, physics informed neural networks. When when you give a drug to your body, actually the physics of the body gets changed over time. How to implement it. So there are some high level, content that we are working on that. Yeah, that I already told. 65 million patients. If you have time, I can show you the app also. I can run the app. खोल सकते हो? दिखाओ. You have time? We already have. You can, if you come to our lab, I can.
Yes, sir, there's a lab visit proposed to your department. sir.
You come to our lab, ma'am. We'll show you. We'll show you all the whatever you are seeing here. They're all deployed as apps. You can run for you, and I can share the link with you, or you can try for yourself. Yeah.
Sure, that will. So, are any of these platforms being used by any of your partners or
These are all in collaboration. For example, the VRDL network is with NIH Chennai.
they are?
There are, I have put it all in public for, but you see, there is some Department of Health is involved, so there are some restrictions. But for anything which is non-profit, we can give it to you. If it is non-profit, non-commercial, you can always use that. Yeah. Rajiv Gandhi Cancer Institute, we are working on a tumor, that lung cancer tumor board. Tumor board is a number of opinion, second opinion, third opinion they take to go for diagnostics. We're making an AI model for that. Yeah, we're working on that. So we have a good capacity on healthcare.
I would like to add, we have started submitting mega projects to scale up these technologies. So we have submitted a couple of them where DRIIV can be one of our collaborating partners.
So where have you submitted to
BIRAC, and there are a lot of calls which have been coming from DST, which are like 25 CR plus, such kind of projects.
Especially for the, low technologies that be really taken up forward to this kind of vendor.
Dr. Amrita, I would suggest that this is one area which could be picked up for propagation. Very good. Thank you. Thank you. We move on to the next one.
Thank you, Dr. Datta sir, for your insights. I would now like to request Dr. Sunita Ratan ma'am, who is the head of the Amity Institute of Applied Sciences, to kindly deliver her presentation on green and clean energy vertical.
Thank you, Kaushiki. So a very good afternoon. I'll be giving a glimpse into the clean and green energy research. My presentation is very, very small, but my group is very large, and many of my colleagues are sitting here, headed by Dr. V.K. Jain, Dr. Basant Zikawar, Dr. Harish, and Dr. Manoj Rola. So actually, we are working, Amity is working towards energy and sustainable solutions. We've got one dedicated institution for that, that is Amity Institute of Renewable and Alternate Energy. It is focused on cutting-edge research in alternative and renewable energy to build future-ready global talents, providing integrated research-based solutions for clean and green energy. And it's not the only institution. This institution is working as a cluster, and many of the other institutions in this campus, like Amity Institute of Advanced Research and Studies, where Dr. V.K. Jain and Dr. Uttam Kumar are collaborating. Similarly, Amity Institute of Applied Sciences, Manoj Rola and Dr. Harish. Amity Institute of Click Chemistry, Amity Institute of Engineering and Technology with Basant Zikawar sir. Dr. Amity Institute of Nanotechnology, Dr. Sumant Upadhyay is there, who is not here, and Amity Institute of Biotechnology. They all are working together towards this mission. We have around 1,293 publications already in hydrogen sector with more than 10,000 citations. And when we are working, we are major area in green and clean energy are hydrogen energy. We're working on photovoltaics, and I'm very much interested to go for waste to energy, but we'll be discussing this later on. When we talk about clean energy, we've got a very big consortium, which has got industry on one side and our academic partners on another side. Our industry partners are there that demonstrate that they believe in our technologies. We've got Aerox Nigen, Ducon Technologies is with us with the financial support as well. Similarly, Green Electrolysis Private Limited and Embetronics are there, who are working with us on a storage and storage solutions. Then we've got academic partners, not only from national, we've got international academic partners, University of Oulu, which I'll be discussing, Lakehead University, Canada. And then we've got very reputed institutions with us who are working for in collaboration so that we can get some solutions from lab to market. So we need this group. Similarly, when I talk about the hydrogen research group, I've already discussed that Dr. V.K. Jain is there, then all my colleagues who are sitting here are there. We all are working together to get notable solutions. And one more thing which Dr. Chandradeep Tandon has already said, that we've got around more than 45,000 Ramalingam and Ramanujan fellows, but I would like to highlight that 8 of them are totally working in the field of hydrogen energy. So we are a very, very rich team in that respect. When it comes to the hydrogen energy, we are not only working for production, we are working for the complete value chain, whether it is production, then storage and transport, and utilization. And our focused area is we are going for large scale photocatalysis. This is what actually the government wants. So this is, we are working on these focused area. Wastewater to hydrogen, again, we are using wastewater to hydrogen. We are making electrolyzers, we are making AEMs films to reduce the cost. Why aren't we driving the hydrogen cars? Because of the cost. So this group is working to reduce the cost so that that can be a reality in the near future. Then we are working towards pilot scale green hydrogen plant. And then we are also using all the AI and computational technologies to optimize our results. And then we aim to have an advanced R&D hub here at Amity University. And then we are in the national point, we are going for national decarbonization goals. We are aiming towards that, which says that drives net zero 2070 and towards Viksit Bharat as well. So therefore, what is our faculty strength? Mainly, we have a vision to drive India's transition towards a clean, secure, and self-reliant energy future by through focusing research in clean energy in alignment with National Green Hydrogen Mission. I think that's the mission which was discussed in the morning, and vision of Viksit Bharat 2047. We have got very good infrastructure capabilities, whether it is advanced instrumentation system, we have got XRD, SEM, GC, photoreactors, NMR, and AI-based safety systems. And then the main thing is that we have, it is complemented by our access to the national and international universities, which are very, very near to us. So this is a location, you can say, advantage also. Then our intellectual capabilities, we have 65 people working for this. They include 32 scientists, 2 Ramanujan fellows. Then our postdoctoral fellows are also there who are working towards this mission, that is 2 scientists. And then we are working in the complete value chain, whether it is utilization, whether it is production, or whether it is storage. So we have all, and 25 PhD scholars are there for energy, clean energy. They are doing their PhDs. When it comes to the technical readiness, that is demonstrated by 14 plus patents, which we have filed, 100 plus publications in hydrogen value chain, and 14 plus projects which have already been undertaken through this. And when we have to move a technology from the lab to the industry, we do not only need scientists, we need a complete ecosystem. So that is why in this cluster, we have engineers, we have economists, we have policymakers, and we have got AI ML experts as well. And this all is enabled by the very good infrastructure at Amity University. As Dr. Tandon has already told, that we've got IPR cell, Directorate of Innovation Technology Transfer, Amity Innovation Center, and Amity Foundation of Science and Technology. We have already completed 5 projects which were given by very good funding agencies like SCRB, ANRF. So these are already done. And based on these results, we have been able to bag more projects in hydrogen research only. And these are all the research which are research projects which are undergoing, and not only from national bodies. We've got the projects from the international bodies also, like UN, AIAA, where we are dealing with the SDG goals. Then we've got from Olu University, and other CSIR and NRF projects are undergoing. When it comes to the patents file, we've filed 11 patents in hydrogen sector only, which is again for all complete value chain, production, storage, and utilization. When it comes to the collaboration and recognition, we are having MOUs with University of Olu, Decon Technology, and Lakehead Universities. And in University of Olu has also given us 5 projects based on our work, and we are moving towards from TRL 5 to 8 with them so that we can scale up our technologies. Then we have also started, it's not only research, we've also started, we want that this hydrogen should be hydrogen energy. We want to cause this awareness among all the people. So therefore, we have started with double degree in hydrogen, the double PhD in hydrogen research. Then we are going to start MSc as a double degree program with Lakehead University. So these Lakehead and Olu University. So this is what our contribution towards the hydrogen energy. So what are the salient features of our research? As we are saying that we are working with photoelectrocatalysis, where we are at a TRL level 5, electrocatalysis, we are at tier level 4, and hydrogen generation through wastewater. This is a very, very good project I will be discussing in my next slide. We have already reached at TRL 6. And then unique value proposition is that we are actually aiming at low cost scaling integration with the existing infrastructure. And then we are not using, because hydrogen, if you know that it is the platinum which is very, very expensive, which makes the hydrogen production very, very expensive. So now in our group is working towards non-noble metal and metal oxide photocatalysis. And then durability we are working on. Whatever the challenges are, present challenges are there in hydrogen research, you are addressing all these challenges. So this is the novelty and innovation, material and design that has harvest full solar spectrum, process and synthesis. We are working on solution and applications. And in all these three, we are addressing the main challenges. And these are some of the research which we has reached to a level where we can scale up and go to the industry. We have the AEMs and ion exchange membranes, which do not require any platinum electrode. It simply require nickel electrodes, and I think the cost can be reduced a lot. Similarly, we've got 2D nanostructures and we are using all metal oxides, metal, MOS2, etc. Again, these are the projects which are funded by CSIR and DST, and we have reached to a value which is required by the industry for hydrogen production. Similarly, we are working for the paired electrolysis also. So all these are the ones. And this is what I was discussing, that this is the photovoltaics, which is the very good project of Dr. V.K. Jain's group, and Uttam Kumar is sitting there, both of them. So here the interesting part is they're using solar light to produce for the electrolysis of water or hydrogen. But this solar light is actually, the hydrogen is produced from the wastewater, which is very, very dirty water. So electricity is produced by the wastewater, and in the process, the wastewater is purified. Very clean water. I think when you will visit the lab, you'll see that electricity is being produced and water is getting cleaned. So we can say it's a very unique in its sense. So this is what we are doing. We have all the research tools which are required for this energy research. These are again. So this is a very small one. I will be discussing, my team would be discussing it further. So I can see from fundamental science to real world solutions, we are working towards the national goal of driving the transition to clean energy. So that was a very crisp. Thank you so much.
Sunita, very good.
So what is the source of the wastewater that you are using for?
It is the Yamuna water.
Dr. Jain.
What wastewater you are asking?
Source of the waste.
So,
Source of the waste.
the wastewater, no? You are asking.
Is it?
You are asking about a wastewater to hydrogen.
Yeah. My question is, from where are you collecting the wastewater?
That's what I'm saying. Actually, this is a very unique technology. We have a big project from DST. The idea is that in the wastewater, we have every type of ions present. It is like a battery. So the specialty which we have designed electrode system based on nanocomposite material and then porosity. Generally, if you put two different materials, you will get a voltage. You will get a very small current. But we have designed the electrode that is a small beaker like this. If you put this two electrodes, we're getting 100 milliampere of current and 1 volt. So this is the patented technology. And at that time, our aim was that my idea was that not only generating the electricity. If you come to my lab, we'll show you one room is illuminated only with the electricity generated from this wastewater. The beauty of this whole system is that when you are using this electricity, then electrolysis is taking itself in the water and water is purified. So under the DST program, we have tested all this water according to the requirement. You can throw in the river after this wastewater we have taken from Kalandikund Nala. You can use for agriculture purpose. Then further to this one, we have gone this electricity to use a fresh water to electricity generate green hydrogen. So without any cost, any electricity from outside, any material from outside, you are generating electricity, cleaning water and generating hydrogen. every industry, those who have come from abroad here, they are attracted with this because there is the cheapest hydrogen, cheapest electricity. So this is a wastewater to evaluate.
Yeah, so the reason I asked this question was, so we are in talks with IOCL to set up a center of excellence with them to deal with various refinery related technologies. So it's going to be a centralized platform which will ultimately unbottle the bottlenecks faced by the refinery sector per se. So if the refinery grade refinery wastewater can also be utilized for this purpose, so the same technology can be, brought under this umbrella when this center is going to actually happen. So we are in talks with MOPNG for that. So that's why.
The main problem in every product, because I was in DRDO for 30 years, so we have produced a lot of products here also. It's not, this is another is a pocket-friendly water purifier. It is a small, like a tea bag. It is a stones. We have processed it with the nanotechnology. You just shake in a glass of water for 1 minute, it will purify. All microbial contamination is removed. We got all awards from Royal Academy London, Power of Ideas, and recently accepted in Army. 3 technologies. Wastewater is also accepted because in wastewater they were saying that we want to use in bunker. In the last moment, if there is nothing, we can use wastewater to generate electricity. Recently they came. And for this water purification, this small tea bag type of system, this Meenakshi will like to comment that Eureka in very close contact.
Yeah, recently the Eureka folks, they have shown interest in this portable water purifier technology. So these are basically the silver nanoparticle impregnated pebbles. And this is the granted patent we have with Amity University. So now we have signed the confidentiality agreement with them and they have agreed to fund us as well. So soon we are going to provide them the samples for the technical evaluation purpose and then we can take the forward accordingly. Yeah, thank you. And you were talking about this wastewater and electricity generation technology. So we have already transferred this technology.
Wants to say something on this technology. What
I was not on this in general, so these are all take-home messages for Krishna actually, for various industrial adoption for CSR and also we are giving.
That every discussion will
No, not matlab, it will be nice
But then again,
because these are having societal relevance. So I think this will really align with the CSR activities that we execute, which are actually are also showcased by us in various forums.
Yes,
So-
sure. So actually, we have already licensed out this technology, this wastewater treatment. You were talking about the water from where the water was taken. So it was the industrial wastewater. It was the water from the this Kalindi Kunj, very dirty. Different types of wastewater from different locations because the impurities vary from location to location and the type of water it is being released from the industry, like pharmaceutical. It has different type of impurities and all. So we have transferred this technology to Deccan Wastewater Treatment, Pune. And now we are scaling up. Yeah. And the third application, which Dr. V.K. Jain has just mentioned about the production of the hydrogen. So this is the new addition, the new application of this whole system. Yeah.
So similarly, we have at least 10 technologies ready in our. The main problem, which we are also feeling when we in DRDO, it was not a problem because we were working for DRDO application. Here, the problem is coming prototyping, as you are saying, bridging of the gap. Because when we have developed this technology, scientists don't have money to do this prototyping. Industry is saying we don't have money to do. They want it ready. So that gap, you have to see how to fill up this gap. That is the most important.
When she comes to lab, please show all this.
Yes.
Very
But
good.
today it is not there in the
No, I
in the
think
program.
Okay,
is there.
she's visiting.
Okay. So many products
I
like that will
request
show you
her-
energy storage, clean energy, photovoltaics. We
take
have a
the-
big department.
We will bring her. Thank you.
Thank you. Thank you, Dr. Jain, sir. Professor Dr. Balwinder Shukla, Madam, respected Vice Chancellor of Amity University, Uttar Pradesh, is a distinguished and a dynamic academic leader with an extensive experience in higher education, research, and institution development. Under her esteemed leadership, Amity University, Uttar Pradesh has strengthened its academic excellence, research initiatives, and global collaboration at a multifold level. To take the program ahead, I would now like to humbly request respected Vice Chancellor, Madam, to kindly deliver her esteemed address.
A very esteemed guest, Dr. Amrita Dawn, the Chief Innovation Officer, DRIIV, on the BSA office, Mr. Krishna Kumar, Board, Head of Institutional Relations, DRIIV, and Mr. Arvind Iyer, the Program Manager, DRIIV, and my very esteemed colleagues, Dr. Lamurthy, Dr. Anand, Dr. Datta, and all the scientists. It's truly a great day for all of us to welcome you here at Amity University, which is research and innovation-driven university. When Honorable Founder President established the Amity Education Group, and at that time itself, he had the vision that India to be the superpower by 2030. And then later, when the vision of Viksit Bharat came, and he aligned all his energies and efforts to aligning with the Viksit Bharat. And the university being the research and innovation driven university, that means the innovation have to be in the academics. To integrate in the students' learning is extremely important. Innovation is important for the research, developing the new products, and which can be taken by the industry. And therefore working very closely and focused way, one side aligning with the national priorities, but at the same time with the societal needs are extremely important. And therefore every year when we do the annual planning, we relook at our research focus, and we see that in last 1 year what all has emerged new, what are the industry needs are there, or the government priorities, and how do we align our research focus with those priorities. And therefore it's not only for the academic which we look at, how we change our curriculum that we remain the relevant, and for developing the skills and competencies of the student to be the employable. And also because the lot of focus is at Amity that we don't only produce the student for the placement, we also look at how the student can start their own ventures or go back to their family business, or may like to pursue their higher education or competitive examination. So we have created a very comprehensive ecosystem for the student support and for their career aspiration one side. And the research becomes extremely important even for the students. When the National Education Policy 2020 was announced, and it was the COVID time, and NEP 2020 was announced when all of us were sitting at home and trying to impart the education in the remote mode of using maybe the Google classes or Zoom classes or MS Team classes. I remember we really exploited the MS Teams like anything, and the vice president of the Microsoft came. He said, we never knew that you can use which was just for small meetings, and you have used the whole for the classes across the Amity universe, whether it's schools or with the universities. And that was also the innovation of our teams, our IT team, and who really immediately, we did not even miss a single day of the academics. Within 24 hours, we were, the online and the remote mode, and the teachers and the students were learning many things together and exploring when the MS Teams. So innovation has been always core of our academic philosophy, whether it's the teaching learning or whether it is the research. And research has been, so I'm also very happy to share with you that in 21, we implemented the National Education Policy 20, being the first university and our first batch of 4 years BA, BSc, they have passed out in 2025. And this year, only day before yesterday, we have completed a new concept we have brought, though the multidisciplinary education was there, but now we have brought the concept boundless. Boundless means that the student have the option to pick up the courses as a minor or a second major from any discipline across the university. And this that they have to see what is their career aspiration. They have to see, what is their bandwidth, and accordingly choose their second, either as a minor or the second major, and depending upon their career interest and their. But as a university, we are there, the kind of the ecosystem to support the students, all kind of the aspirational needs and the academic needs. So the research being the very important aspect, and our honorable founder president always emphasized on the two things. First, that whatever the research you do, you must get it patented. And that's very important. And just filing the patent is not good enough unless you are able to commercialize, unless you are able to either transfer the technology. And very innovative also scheme came in the university that faculty who are doing the research, maybe they would like themselves to start their own venture. So therefore, we promote the faculty startup also, that we have already the 2 faculty have started their own ventures. Honorable founder president has given us the target to have the 25, at least 25 faculty startups. So we are having some more of the proposals which have come from the faculty we are examining. I'm very happy to share that Dr. Nin has already shared that we have the MIT Innovation Incubator since beginning. We have, but now we have also been granted by the BioNest, and where we have the 4 focus area, where we will be working in the health and biopharma is the one of the focus area where we have, and the agro and food technologies that is the second focus area, and the third one is the environment and climate change is a focus area, and then the fourth one the AI for the bio-based solutions, and and all 3 that have been presented by our team here. So that kind of the research we are doing and the kind of the patents we have filed and the kind of the technology transfer we have done, and because these are also the aligned with the national priorities are there. So we are very happy that when we saw your presentation, what the DRIIV is doing, and we are looking at what as a MIT we are doing. So there we could find that so much synergy is there, and because aligning with the national priorities are extremely important. And one thing what our honorable founder president always emphasized right from the beginning, that have the strong connect with the industry. And whether it's academics and whether it's research, both have to be aligned with the industry requirement, whether you're developing the future talent, or whether you're developing the such solutions. And just publishing the papers is not good enough. The paper publishing is important, but at the same time is what the outcome is of your research or any activity. And Dr. Nan has shown in his presentation initially that the various missions are there. The ultimate mission is the mission outcome. And even that today we will be looking at from here that what we have to achieve and how we have to achieve, and the input which we will be receiving from you, what are the things we should be doing as a MIT University, because the university is committed to the nation building. And also I would like to share with you that Honorable Founder President have emphasized a lot, and he said that when we were deciding our academic philosophy, and a couple of things which much later came in the National Education Policy 2020, but it was more that behavioral skills, communication skills are integral part of the academic. Foreign language is integral part of the human values, are the integral part of the education system. But when the AI came, And AI was not just for the engineering or science domain. AI is a universal. So all our students, whether they are from the history or from economics, from engineering, they all study at least one course in artificial intelligence. Now we have offered as a AI as a minor, as well as the second major for the student. They have to pick up whether they would like to do the minor or they would like to do the second major. So therefore, MIT University is very focused, and my scientists are highly committed and picking up the partnership with the industry. And I'm very happy to share when we are talking about this hydrogen. Tomorrow, our partner Ducon from USA, the team is here in India, and they were checking with me that what could be the convenient day. So I said, we will meet tomorrow 11 o'clock. So the team is coming to discuss with us on the various areas of collaboration, because we had initial discussion when we happened, and a couple of technology we discussed, but at the same time, the focus was on the storage part, that we will do the production and they will be helping us in the storage, because that's what the Ducon Technologies expertise there. So that we will be further discussing, as well as the technology which we have developed, which they can take from us. So we have the very strong partnership with the industries. It's not within the country, but for the outside the country also. So with this, I once again extend very warm welcome to Dr. Amrita ji, to Dr. Vishal ji, and everyone who have the come, and Mr. Krishna Kumar ji, Mr. Arvind Iyer ji, and we are really missing Dr. Vishal Chaudhary ji, and we understand that it was so important for him to be present there, but we really are missing, and I sent a message to him, and he said he will try to come. So we don't know. We are just keeping our fingers crossed.
Right now.
I just got a call from Vishal sir. So he is right now sitting in a block, in such a block from where coming online is not possible. So he was very much apologetic. But of course, as we grow in our engagement and collaboration, I'm sure this kind of interactions will keep on happening. But thank you so much. It was a very nice experience, and getting to know all the wonderful work that has been carried out in and is being carried out in your university. And we definitely see a lot of synergies and DRIIV under the esteemed leadership of Vishal sir would really explore how we can collaborate on multiple aspects.
Yeah. See, our very dynamic chancellor, Dr. Atul Chauhan, he always emphasized we build the partnership and we bring the synergy together, and for the common mission of one side the Viksit Bharat, but at the same time to make this world a better place to live. And with this, thank you very much for visiting Amity University, and look forward working together. Thank you.
Dr. Koshiki, Dr. Amrita, you mentioned about a mission of oil spillage management. We have an excellent technology from Dr. Ranu Nayak. We have specially called her for this meeting. So can you just brief about this nano sponge, polymer-based nano sponge?
So, a very good afternoon to one and all. Myself, Ranu Nayak. So, I have a small startup under the umbrella of Amity Universe with blessings and guidance from founder, president, sir, vice chancellor, ma'am, and Selvamurthy, sir, and many more. Tandon, sir, they've always been guiding me for this. So, our technology, our startup is based on nanosorbent technology. What we do is, as sir said, we take care of oil spillage, large oil spillage, as well as our nanosorbents. They can be accommodated in resource-free areas in ETPs, small ETPs or mid-level ETPs, as well as we have a unique use case which we have given recently to the defense sector towards transportation, storage, and safe transportation of fuel using our nanosorbents. So these nanosorbents are actually biodegradable as well as they are reusable, and the amount of oil they can absorb is almost like it ranges from almost 10 to 25 times than their own weight, depending on the different types of fuel. We have tested with various type of fuels, including kitchen oils, crude oil, engine oil, and the gasoline, diesel. Most the organic pollutants also we have checked on that, and this startup was actually created with under the guidance of BPCL. So they have helped us to validate our technology. They have completely validated our process, and we have also validated the concept with third-party labs. The same sponges can do antimicrobial, like remove pathogen load from wastewater as well. Not only that, so BOD, COD, a lot of TSS, a lot of contaminants can be removed by these sorbents.
You mentioned about the shapes and the
Yeah,
shape.
so I got some, sir, if you can actually pass on. So these are extremely lightweight sorbents. They come in various shapes. So I've just brought a sample of it. They're highly buoyant. They remain floating in water even when they have absorbed oil. And you can squeeze and remove the oil from them. So it's only mechanical compression without any electrical requirement of extraction of the fuel. And the fuel retains its purity, which also we have got it validated.
100% recovery is possible?
95 to 97% recovery is possible based on the viscosity of the fuel. Like if it is crude, it's going to be around 95%. But if it's a light oil, we can extract 97 to 98%.
She has also developed the sheets. Why don't you mention about?
Yes, there is a disposable nanofibrous sheet, which is one-time usable, but then the amount of oil it can absorb, that is typically for oil spill management, it can absorb almost 35 to 50 times its own weight.
Okay.
And these are completely biodegradable with natural fillers. So these are polymer materials, synthetic polymer materials.
And you said it can also purify water, so it can be used for augmentation of the existing STPs
Yes,
and ETPs.
but I don't say that after purification it is drinkable. But yes, it is usable like any industrial effluent. It can treat. Yes, we haven't gone through that level that we can say that it is drinkable, but we have checked on various parameters given by CPCB, which it aligns.
Okay, great. So this kind of solution can also be pitched at DJB, right? Because you mentioned ETP, so that's why DJB has a lot of, defunct CTPs and ETPs.
Yes.
So they are trying to, I think, either augment the capacity to make them running again or commissioning new ones.
Yes.
So this is very interesting since
and our target is automotive industries also, other than oil and gas, because most of the automotive industries and mid-scale industries, they can have their own small-scale ATPs where you don't need the big setups. You can use these sorbents, you clean your effluent, and then again reuse. You mechanically compress, get rid of the oil and reuse. And these can even soak oil from the emulsion. We have tested that also and got it verified, validated from BPCL.
Yeah. So BPCL didn't, what was
So we are in talking terms with them. So they have a seed fund program, Ankur. Whenever it'll be active, we'll apply through them. But anyways, we keep taking, assistance from them. So we are trying to look for some seed funds where we can try a pilot scaling. But other opportunities also I'm equally looking for.
Sure. Thank you for sharing.
Dr. Nair, you can also share the for the civil aviation. We will try to implement it at the all airport authority. Also for the defense sector, ma'am.
So I'll share these pamphlets with you.
So Krishna and Amrita, this will be very, very valuable. We would like to look at.
Particularly for the defense sector and for the CAPF forces, I think this is very, very usable. We will align a meeting and then we will get this done.
Yeah. As in the Spirax Women Leadership STEM Entrepreneurship Program.
So Kaushiki, now I would request Mr. Arvind Iyer to say a few words. He is the program manager of DRIIV. So would you like to speak from here or would like to go there?
Thank you so much for the warm welcome. I had a lot of new experiences here. I met all of them and they are really smart and genius and they have a lot of innovative solutions. And I would like to thank Dr. Silvamurthy sir. So fortunately, he's also from the state where I belong. He's also from Tamil Nadu and I am also from Tamil Nadu. That was the first instinct. And I was just talking to him about the PSA sir. Professor Ajay Sood is the current PSA sir and Abdul Kalam ji was the first PSA. And he was sharing his experience of working with Dr. Abdul Kalam ji. And I was very amazed and thank you so much. And thank you so much for the Chancellor ma'am, thank you so much for calling us here and giving us an opportunity to interact with you all. And this definitely, as Dr. Amrita mentioned, there will be a lot of interactions in the near future, and we will develop this partnership to a different level. Thank you.
Thank you so much, sir. After listening to all the deliberations, the House now stands open for discussions and interactions. I would like to request Dr. Chandradeep Tandon, sir, to kindly steer the discussion.
Thank you so much. So we had very informative presentations from our faculty members and also from Dr. Amrita Dawn. Few words from Dr. Krishna ji and also Dr. Ahir also. So I would now like to invite our faculty members, owing to paucity of time, for quick interactive session. So whosoever wants to express themselves, who haven't done it before, so they can just quickly, I will hand over the mic to them just for some time. Okay?
I think why don't we start with mechanical engineering? Your car.
Absolutely right.
He has not spoken. Basan Singh Sikarwar.
Thank you very much, sir.
Closer.
Yeah.
Check.
So I'm a Professor Basan Singh Sikarwar, heading the Department of Mechanical Engineering. My expertise in thermal and fluid engineering. Already, ma'am is discussed about using the hydrogen in automobile sectors. So we are using the two approach to using the hydrogen in automobile sector. One, we have to be use the enrichment of air, because air has a different contents. So hydrogen, so we have to be enrich the hydrogen in air. Then we have to see what is the combustion behavior. So definitely we have to reduce like fuel consumptions, all these things. Second, we have to directly inject the hydrogen. So hydrogen is a primary fuel, and the first case hydrogen is a secondary fuel, like this. So these two areas we have to be see the combustion behavior. And in principle, I am a mechanical engineer, and I have been used the many techniques, many things, especially for a passive coolings. And
Basan, can you talk about that water from the dehumidification?
correct.
That is very valuable.
Yes. And second area, I'm working, develop a super hydrophobic surface for water harvesting from atmosphere. So you know that there is a plenty of water in atmosphere, and they are in a spreading, and we have to be collect that effectively and efficiently. So we develop the systems that can be condense the water in a super hydrophobic surface very effectively and efficiently. And we develop the small device that can be collect the 25 liter per day water when humidity is more than 50%, 50 to 60%, and the temperature is 37 kind of. So like Calcutta, Chennai, Mumbai, these are the area, Visakhapatnam, all these are the area where the humidity is always more than to 60%. The device is available, all these things, kind of this thing. Second, I am working in one of the important DRDO projects. This is very, very important project because they want to be a cooling of the next generation electronics. So people are asking many, what do you mean of next generation of electronics? I'm saying that the electronics which can generate the heat more than to a critical heat flux, 5 into 10 to power 5 watt per centimeter square kind of. And most of the electronics like you have BrahMos, you see the direct weapon systems, high power laser systems, they are a next generation electronics because defense sector want to this type of a equipment. So cooling is a very, very important of these things because without the cooling, these electronics definitely they cannot be work and they malfunction, all these things. So we are working on a pump to two-phase cooling system. This is a new type of a technology. There is several technologies, but pump to two-phase cooling technology is one of the new technology.
Good.
So,
I think we will present to them sometime. This is very important.
yes.
These two technologies, one is for the cooling, the other one is water. Wherever in the desert areas or in the coastal belt, how do you use the humidification which is available in the air? From that you generate water. Good, thank you.
Correct. Thank you very
Maybe
much.
Manoj would like.
Myself is Dr. Manoj Garg. I am a Assistant Director at Molecular Medicine and Stem Cell Research, and we have met 2-3 times at PSC meetings. And Dr. Kamal Rawal has already present AI in healthcare. I am part of that. So basically, my expertise to looking at the long non-coding RNA and miRNA with Priyanka Jain, how they can be used as a diagnostic and prognostic marker using a drop of blood rather than doing the whole screening. And then we are also developing new small molecular inhibitor, which can further go for the treatment and diagnosis purpose. And so, thank you.
He is working on a triple conjugate for cancer stem cell. Right, can just give it to him.
Good afternoon. So Dr. Manoj and Dr. Priyanka, I'm from the same institute, Molecular Medicine Stem Cell Research. And we have around 15, 16 faculty, 15 faculty members who are working in various areas of cancer biology as well as infectious diseases. And with the aim of trying to find solutions for the most common cancers such as breast, prostate, lung, liver, and also pancreatic. So looking for small molecules and innovative solutions.
Manoranjan, can you, about biorefinery, algal biorefinery, just 30 seconds. Niranjana.
Good afternoon. I am Dr. Manoranjan Naik, working in Amity Institute of Biotechnology. So after completing 7 years of postdoctoral experience at IIT Kharagpur and KAIST, I joined at 2021. Then I developed a research laboratory, biorefinery and bioenergy research laboratory, where we are focusing, exploring different microorganisms like microalgae, yeast, and bacteria in the field of energy, environment, and health. So we are using microalgae for biodiesel production and treating wastewater, different wastewater we are treating, like municipal wastewater, dairy industry wastewater. So we are using cocktail wastewater also by mixing different wastewater, as well as we are remediating solid waste, like poultry litter extract. That is also a major problem in the society. We are treating that solid waste using those wastewater and solid waste as nutrient source, as well as recently we received a project from DBT Viract for carbon dioxide sequestration. Means the industry emitting carbon dioxide, which pollute the atmosphere. We in our biorefinery we are treating or sequestering that carbon dioxide in this microalgae cultivation system. And third problem we are solving, that is energy, environment, and health. We are targeting for lutein. Lutein is an anti-cancerous product. We are targeting for lutein. In lab scale, we have optimized, and also we have developed in pilot plant at the Amity University, 100 to 200 liter capacity, where we are using wastewater and using flue gas for the cultivation of microalgae yeast co-culture, microalgae bacteria aquaculture for the production of biomass, and from biomass to bioenergy we are targeting in this biorefinery. Thank you.
Dr. Amrita, this one is also very important. I would request you to see it. Manoranjan has developed an excellent biorefinery.
Very interesting to know that microalgae can coexist with yeast.
Yes. Very novel with you. Yes. Great. Now, can you give it to, no, not Pooja has spoken.
I have
Okay.
spoken, but I'll just say a few words. I head the biotechnology department. We are a very large institute. We have 85 faculty members. And when we listen to your talk, what I can say is that within the biotechnology department, we have large number of scientists who are working in similar areas, whether it is AI in healthcare or climate, environmental sustainability. Like Dr. Manoranjan is a part of our, Dr. Shashi is part, there are many more. So I think we see a lot of synergy, and when you come to the department, I would be very happy to take you across some of these laboratories which are doing wonderful work, and we can take the talks forward from there. Thank you.
Thank you, Pooja. Amit Karkwal.
I'm Dr. Amit Kharkwal from MIT Institute of Microbial Technology. So as Dr. Nutan has shown, Rootonic and HNB9, so these are basically fungal root endophytes, just like mycorrhiza, but they are culturable. And the advantage is that we can use these biofertilizers in conventional agriculture with existing chemical fertilizers, and we can this can lead to reduction in the chemical fertilizer input. That is very important for the peri-urban farming systems. So where the customers of Delhi NCR, they can get safe and healthy, nutritious food. So we have already transferred the technologies, and multiple technologies are in pipeline also, which are being developed, like bio NPK and biopesticides. So these all are relevant to the for the use by peri-urban farmers for use in Delhi NCR. Thank you.
Amrita,
My
again,
request
very
here.
important.
Yeah, my request to the rest of the colleagues are that if 10 seconds, if you can just please.
Okay, thank you, ma'am. I'm Nirupma Prakash, heading Amity Institute of Social Sciences. Now, one thing which strikes me is that we are talking of lab to market. So, I mean, field is our social laboratory. So whatever and scientific pursuits are being taken, they take it to the society. Now, one thing important for Amity University, I would like to say here is that under the guidance of Honorable Vice Chancellor Madam, since 2014, we are running a course at both a UG and PG level where students take up projects for the semester and in the community. So that also includes, apart from other clusters, let's say health, in terms of raising awareness, menstrual health, and so on and so forth. And this is mandatory for students. They earn 2 credits and they cannot get their degree unless they do this. So that is inculcated amongst the students that they have to take it to the society, and also our Amity Human Value Quarter, the vision of Honorable Founder President Sir, and also Honorable Chairperson Madam, our Vice Chancellor Madam, that there's a quarter where each student goes to the community, which is running right now. And it culminates on 27th April with the birthday of our Honorable Chairperson Madam. Very quickly, 10 seconds. I would also like to say that apart from our faculties are all involved in sociological projects, I have been fortunate to have taken up a project on science and society, which was funded by Auto CRC from Australia. And this was on perception of consumers towards alternative energy transport. And this was 4 years ago, which I had taken up with for electric vehicles. And we presented the findings to the chairman of Maruti, and he was quite impressed with the Amity University. Thank you.
Good afternoon, sir. I'm Dr. Manoj Chandra Garg from Amity Institute of Environmental Sciences. I am working on the field of forward osmosis membrane system that basically using treating the textile industry wastewater by using the draw solution as a fertilizer solution. So we are extracting the water from the wastewater by using the forward osmosis membrane system and dilute the fertilizer solution that can be further using in the fertilizer irrigation system. I am also working in the bioremediation by the help of absorption by using the different materials, biosorbent materials for the treatment of the different industrial wastewater. And we are optimizing the different parameter by using the artificial intelligence and the RSM. Thank you so much.
Good afternoon, everyone. My name is Dr. Haris. I belongs to AIAS, Amity Institute of Applied Science. Professor Sunita Madam already introduced us a little bit. I have been mainly working on the scalable hydrogen technologies. In addition to that, I am also involved in multiple other areas, especially connecting Amity University with the University of Oulu, Finland. We have already plan to initiate several programs, especially in hydrogen sector. Also, other areas like energy storage as well. At least yesterday we were discussing that we will probably also initiate master program in battery as well. So it's not only hydrogen. Basically, we are trying to cover the complete, let's say, clean energy and green energy initiative. We are also planning to, at least we have already initiated lots of activity in order to build the center of excellence in the clean energy and green energy part. So in connection with lots of industry partners, also international universities, and at least part of the activity, Vice Chancellor ma'am already mentioned that we will be having discussion tomorrow. So it's a complete ecosystem that we are trying to create here. So thank you very much.
So I'm Dr. Priyanka Jain. I'm working at AIMSR with Dr. Manoj Garg and Dr. VC Das. So my project is really focused to understand the coding, non-coding RNA interactions in which we are trying to see RNA-based biomarkers which can be used as a prognosis in the cancer. Thank you.
Good afternoon. Myself, Dr. Shashi Sharma. I am from MIT Institute of Biotechnology. Basically, I am focusing on the microbial production of the biosurfactants in order to replace the synthetic surfactants, because we know that synthetic surfactants are causing a havoc in the environment. So we are basically producing the glycolipids and the lipopeptides, and we have gone to the TRL level 3, where we were able to produce around 19.3 grams of the this rhamnolipid. And rhamnolipid finds a huge application in the skincare, in the agriculture as a plant growth promoter, even for the xenobiotic compounds emulsification. Even in one of the slides, we have shown that how these organisms or the biosurfactant can actually emulsify the oil sludge, which was your point actually. And moreover, we are also working on the bioremediation using the white rot fungus, in which we have concentrated on this LDPE milk packets, because we find everywhere they're lying, right? Everybody is using and just throwing it. So why not to use that? And we have biodegraded that using our white rot fungus with the production of the lignin modifying enzymes as well. So around 60% weight in reduction was obtained. Also, we are now heading towards the formulation of some, for the cosmetics, especially for the psoriasis problem, not for the cosmetics, but for the psoriasis problem, in which we are tying up with the IHBT, CSIR IHBT, to formulate with the herbal formulations and our biosurfactant, so that we can go for some treatment formulation, because the biosurfactants also show the pharmacological properties, like they are anti-cancerous, they are anti-inflammatory. So with that add-on properties, we are moving ahead. Thank you so much.
Good afternoon, everyone. Myself, Dr. Renu Dhupna. I'm an Assistant Director in the Amity Institute of Environmental Sciences. So being a very important part of this department, we have already 10 faculty members, and all the faculty members are working in all the thematic areas of environmental science. Like a few faculties are working on the wastewater treatment plant, few faculties are working on biochars, biofuels, then the impact of toxic chemicals on the plants, crops, and some faculties are working on the development of the model for the climate change modeling and disaster management. And nowadays, the most important parameter which is arise in the NCR region, that is the urban risk factors. So few faculties are developing the models on the urban risk factors, and we have a very good collaborators with private sectors and government sectors. And being a part of this important department, we are a number of training programs, workshops, conclaves, and hackathons are conducted in collaboration with Ministry of Earth Science, Ministry of Environment, Forest and Climate Change, Indian Meteorological Department, and National Institute of Disaster Management. Thank you. And recently, Ma'am, recently we received one project from Uttar Pradesh Pollution Control Board, where they give the 3 stations and we are doing the monitoring of the PM 2.5, PM 10 and SOx and NOx in Kasna, Surajpur and in Rabupura village near to the Jewar airport, ma'am. Yes, ma'am. Ma'am, we're developing, the machines are already installed in these Honda Power, CNH and the Rabupura for 2.5 and for PM10 and SO2 and NO2. And we are taking the 3 readings at 6 p.m., 2 p.m. and 10. And for that time, it will be for 24 hours, 8 hours and 4 hours, ma'am. Ma'am, the field assistants are already located there and they are doing the taking the readings and we are doing the analysis of the samples in the lab. Thank you, ma'am.
Good afternoon, ma'am. Myself, Dr. Manish Kumar. I'm working at the MIT Institute of Environmental Sciences. Having PhD in applied environmental microbiology, I had a couple of postdocs from EPFL Switzerland, then Hong Kong Polytechnic University. And currently I'm working on biochar and their environmental application. And we have a very good collaboration, like you mentioned, UWA. Kanamud Sidki is there. Nutan ma'am is like, there is one more professor, Professor Nanthi Bulong. He is like a super professor, what we call him. So I had a collaboration with them. Then I had a collaboration with Kansas State University and then the Hong Kong Polytechnic University. So in that collaboration, I am working on biochar and then their environmental and agricultural application. Thank you.
Good afternoon, all. I'm Dr. Rumi Dev, and I'm an anthropologist basically. So I do field work and a lot of community health, where I have worked on HIV, maternal and child health, lung cancer screening, and thalassemia. So we go to the field with certain, we collect the samples and the data, and we try to correlate. And we are collaborating with various hospitals, organizations, and that's how I do my work. And that's a lot of, community and public health. Thanks. Yeah, I work in Northeast in a big way. I work amongst the tribals of Northeast. So I got to know a lot of things. We talk about AI and everything, but when you go to the field, the acceptance of the people is very limited. So we should make an effort. I think it's it's mandatory for the government to see that it goes to the people and they should be sensitized about it for the benefits of it. Thank you so much, everyone.
Hello, ma'am. I'm Dr. Uttam Gupta. So when most of my work have been explained by Dr. Sunita ma'am and Dr. V.K. Jain, but one of the work which I highlight now is that since the wastewater treatment is a bigger problem now, and most of the industries, they have different kind of waste. And then for that, we sometimes use microbial treatment, sometimes we put chemicals. So we have designed a universal system where we have made an electronic circuit, electronic grids, where when you insert in any kind of water, the water gets purified itself, if whether it's organic or inorganic waste. So you do not have to have multiple vessels where you put different chemicals or microbes. You can just insert the system inside and it purifies the water. So at the moment we are scaling it up, now we are doing large amount. I think that would be a very nice technology because now we don't need a lot of centers, but only one plant we can do that.
Thank you, Dr. Uttam. Thank you, everyone, for the deliberations. I would now like to request Dr. W. Selvamurthy, sir, who is the president of the Amity Science Technology Innovation Foundation, to deliver the closing remarks for today's session. Please, sir.
Thank you very much. I'm sure all of us will agree that we had a wonderful, fruitful, productive, and constructive meeting together. I want to thank first founder president who is responsible for this. You know what happened about 2 months ago? Founder president visited PSA office. Not only he, 2 chancellors, both Dr. Atul Chauhan, Dr. Sim Chauhan, Mr. Amol Chauhan, one of the major trustees. And then I was fortunate to be there in that. So Chancellor presented a gamut of activities in research and innovation. And so that is how the whole genesis started. So then he said that we should do a lot of close interaction with PSA office, because you do a lot of work, even though you are not a funding agency, but you are the fulcrum of the science for the whole government. So that is why the One Health, then rural technologies, everything was presented by PSA. Then the site S&T clusters, because when he talked about it, then founders said that we have a lot of technologies which can go into this application through this channel as well, because we have our own mechanism of technology transfers, and we have a Directorate of Innovation and Technology Transfer. We work with state government, central government, and with the stakeholders. So he said that this is an excellent forum where you have already made a model. 8 of these clusters are doing great job. So founder said that why don't we now link with this and see how our innovations can reach the society through this? Because he has kept a philosophy that our research, all our research should culminate in any one of these, either a product, technology, or a process, or a solution to a problem. So this is what is the common denominator in all our research, which we have created here. So your visit, we have attached a lot of importance because founder himself has navigated the whole program. Then subsequently, the Chancellor, Dr. Atul Chauhan, also has given his patronage to this, the linkage and partnership we are establishing with Amity Group with you. And so we are so delighted to welcome and then thank particularly Dr. Amrita Dawn, who was here, and I could see the length and breadth and depth and the love and affection you have for Amity, because your daughter is part of our system and you are part of our system as well. So he's the chief innovation officer. So we will work with you, and then we will also like to thank Dr. Krishna Kumar Gaur. He is the head of the institutional relations. He works with the government, central various departments as well as state governments, and all the official machineries of the government. So you are very important to connect with all the stakeholders. So thank you so much, and then we will work with you as well. Mr. Arvind Iyer, program manager of this DRIIV, and certainly we will take your guidance, and you are here. So we will work with you as well. So I would like to also thank all these, our faculties, the deans, the Pro Vice Chancellor, Dr. Chandradeep Tendon, and all those who contributed to the deliberations. They are just brilliant. We are so proud to have such a very distinguished faculty, scientists in Amity. You have only seen the tip of the iceberg. Otherwise, Amity is having a large number, and what you have seen today is just a chalak dikhane. You have shown a chalak here. So, but then we would request you to come more once again, once, twice, because it is your university now. And now we would like to also be part of your mission. And the whole purpose is to showcase some of the technologies which are relevant to DRIIV. That is how we chose this, who should be the people who should attend this. So our Vice Chancellor, Dr. Balvinder Shukla, took a lot of interest. She held a meeting yesterday, late in the evening, and also even earlier. And then with Dr. Chandradeep Tendon, they made the scientific program. So I want to thank our Vice Chancellor. Let's give a big clap to our Vice Chancellor. And also Dr. Chandradeep Tendon, the Pro Vice Chancellor, and all those who are connected, particularly all the HOIs who participated in the meeting, and you are doing a great job. And now coming to some of the areas, how do we move forward? Because we have only just shown. I would like a small round tables and a thematic, whether it is water technologies. So which are the ones, either we come to your office or you can come over here and then look at the in-depth and then strict, maybe 1 hour we sit together for each cluster and then arrive at how do we move forward together with you. And then you can connect with those stakeholders so that the technology and innovation goes to the people. So this I would request all the 3 of you to look at this. Also, we will tell Dr. Vishal Chaudhary as well. And otherwise, it has been a wonderful visit. I want to thank also the S&T warriors who have been responsible to organize this. I'll start with Dr. Harjinder. Let's give a big clap to Harjinder, who coordinated this activities. Then Dr. Koshki, very, yeah, she's the one who compared the program. Parul, Kavita Joshi, Upriti, Vidhi Goyal. So all these people, S&T warriors, founder president has created a SNT outcome, SNT warriors. So as Vice Chancellor mentioned, every activity should have a sustainable outcome. Not that what you have done today, it has an outcome. It has to be sustained to make an impact. Then only the outcome becomes tangible. So he always says outcome has to be tangible, not only intangible. So this we start with intangible, but then it has to be leading to tangible. These are the warriors who drive this. And so I want to thank each and every one of you here. And I'm sure we will take it forward. We want to contribute to Honorable Prime Minister's vision of Viksit Bharat. All of us have to come out of our comfort zone, stretch ourselves, work with people, connect with people, bring synergy, and work as one Indian team. Then we will make an impact. Otherwise, science innovation will become only demonstration in the laboratories and the universities. But what we want to see is how it impacts the life of the people. How do we connect science to society? This is what PSA office does. These are the people who are driving the connections between the scientific laboratories, academia, to the society. So you are doing a great job. Let's give a big clap to Dr. Amrita, Dr. Kaushal, and also Dr. Arvind. So thank you so much and come more often. And I want to thank all of us who are responsible for the success of this meeting. Thank you so much.
Now, the founder president always says that once somebody has visited the Amity, becomes the Amitian, once Amitian, forever Amitian. So it's your Amity, so you have to visit more often. Thank you.
Thank you, everyone. I would like to once again extend my sincere gratitude to the distinguished guests of the day for sparing their valuable time and visiting Amity University. We sincerely look forward to take the initiatives ahead in a favorable manner. Now it is time to felicitate our guests, and I would like to request our Honorable Vice Chancellor Madam, Dr. Selvamurthy Sir, and Dr. Tandon Sir to jointly felicitate Dr. Amrita Ma'am and Mr. Krishan Kumar Kaur Sir and Mr. Arvind Iyer Sir with a memento and a gift from our side. Please.
Yes, ma'am.
Yes, can I request everyone to come together for a group photograph, please?